What we're going to do in this video is get some practice applying u substitution to definite integrals. So let's say we have the integral. So we're going to go from x equals 1 to x equals 2, and the integral is 2x times x squared plus 1 to the third power dx. So I already told you that we're going to apply u substitution, but it's interesting to be able to recognize when to use it. And the key giveaway here is, well, I have this x squared plus 1 business to the third power, but then I also have the derivative of x squared plus 1, which is 2x right over here. So I could do the substitution. I could say u is equal to x squared plus 1, in which case the derivative of u with respect to x is just 2x plus 0, or just 2x. I could write that in differential form. A mathematical hand-wavy way of thinking about it is multiplying both sides by dx. And so you get du is equal to 2x dx. And so at least this part of the integral I can rewrite. So let me at least write. So this is going to be, I'll write the integral. We're going to think about the bounds in a second. So we have u to the third power. U, do the same orange color. U to the third power. That's this stuff right over here. And then 2x times dx. Remember, you could just view this as 2x times x squared plus 1 to the third power times dx. So 2x times dx, well, 2x times dx, that is du. So that and that together, that is du. Now, an interesting question, because this isn't an indefinite integral. We're not just trying to find the antiderivative. This is a definite integral. So what happens to our bounds of integration? Well, there's two ways that you can approach this. You can change your bounds of integration, because this one is x equals 1 to x equals 2. But now we're integrating with respect to u. So one way, if you want to keep your bounds of integration, or if you want to keep this a definite integral, I guess you could say, you would change your bounds from u is equal to something to u is equal to something else. And so your bounds of integration, let's see, when x is equal to 1, what is u? Well, when x is equal to 1, you have 1 squared plus 1, so you have 2. U is equal to 2 in that situation. When x is equal to 2, what is u? Well, you have 2 squared, which is 4, plus 1, which is 5. So u is equal to 5. And you won't typically see someone writing u equal to or u equals 5. It's often just from 2 to 5 because we're integrating with respect to u. You assume it's u equals 2 to u equals 5. And so we could just rewrite this as being equal to the integral from 2 to 5 of u to the third du. But it's really important to realize why we changed our bounds. We are now integrating with respect to u, and the way we did it is we used our substitution right over here. When x equals 1, u is equal to 2. When x is equal to 2, 2 squared plus 1, u is equal to 5. And then we can just evaluate this right over here. Let's see, this is going to be equal to, the antiderivative of u to the third power is u to the fourth over 4. And we're going to evaluate that at 5 and 2. And so this is going to be 5 to the fourth over 4 minus 2 to the fourth over 4. And then we could simplify this if we like, but we've just evaluated this definite integral. Now, another way to do it is to think about is to try to solve the indefinite integral in terms of x and use u substitution as an intermediate. So one way to think about this is to say, well, let's just try to evaluate what the indefinite integral of 2x times x squared plus 1 to the third power dx is. And then whatever this expression ends up being algebraically, I'm going to evaluate it at x equals 2 and at x equals 1. And so then you use the u substitution right over here, and you would get, this would simplify using the same substitution as the integral of u to the third power du, u to the third power du. And once again, you're going to evaluate this whole thing from x equals 2, and then subtract from that, it evaluated at x equals 1. And so this is going to be equal to, well, let's see, this is u to the fourth power over 4. And once again, evaluating it at x equals 2, and then subtracting from that at x equals 1. And then now we can just back substitute. We could say, hey, look, u is equal to x squared plus 1. So this is the same thing as x squared plus 1 to the 4th power over 4. And we're now going to evaluate that at x equals 2 and at x equals 1. And you will notice that you will get the exact same thing. When you put x equals 2 here, you get 2 squared plus 1, which is 5 to the 4th power over 4. That right over there. And then minus 1 squared plus 1 is 2 to the 4th power over 4. That right over there. So either way, you'll get the same result. You can either keep it a definite integral and then change your bounds of integration and express them in terms of u. That's one way to do it. The other way is to try to evaluate the indefinite integral. Use u substitution as an intermediary step, then back substitute back, and then evaluate at your bounds.